In this unit, we will talk about strategies for comparing fractions. In particular, we will talk about common misconceptions that arise when comparing fractions, as well as different strategies for comparing fractions using the meaning of fractions, including comparing fractions with common denominators or common numerators, comparing fractions using benchmark numbers, and comparing fractions by finding a common numerator or denominator. When we compare whole numbers, it is usually evident when we are comparing the same or different types of things. However, with fractions, it is easy for students to make inappropriate comparisons without realizing it. Here we see two rectangles where the shaded parts represent the fractions 2/3 and 3/4. While it is true that 2/3 of the first rectangle is greater than 3/4 of the second rectangle, it is not true that 2/3 is greater than 3/4. This is because each rectangle is a different size, and thus the fractions refer to different wholes. In order to compare fractions, they must refer to the same whole. When comparing fractions, students should be able to reason from the meaning of the numerator and the denominator. The denominator tells you how many pieces make a whole, and the numerator tells you how many of those pieces you have. In other words, the numerator tells how many pieces, while the denominator tells the size of the pieces. So if we have 5/3, that means we have 5 pieces, and 3 of those pieces make a whole. We can also phrase this using the language of unit fractions. The numerator tells you how many unit fractions you have, and the denominator tells you how big the unit fractions are. So if we have 5/3, that means that there are 3 unit fractions in 1, and we have 5 of them. Remember, when we represent a fraction on a number line, it corresponds to a point. In 3rd grade, students compare fractions with the same denominator. The reason here is just like reasoning with whole numbers. 9 yo-yos is more than 3 yo-yos, and 9/4 is greater than 3/4. We can also see that 9/4 is greater than 3/4 because it is further to the right on the number line. In general, if two fractions have the same denominator, then the pieces, or unit fractions, are the same size. If there are more pieces, the fraction will be greater. In 3rd grade, students also compare fractions with the same numerator. The first step is to compare unit fractions. 1/6 is greater than 1/10 because the pieces are bigger if you partition a whole into fewer pieces. We can see this in terms of a situation involving sharing a sandwich with friends. If 6 friends share a sandwich equally, each person will get a bigger share than if 10 friends share the same sandwich equally. If we have the same numerator, we see that we will have the same number of unit fractions, but the size of the unit fractions is different. So 4/10 is less than 4/6. On a number line, 4 longer steps get you further to the right than 4 shorter steps. In general, if two fractions have the same numerator, then the fraction with the bigger unit fractions will be greater because you have the same number of unit fractions. In 4th grade, students compare fractions with different numerators and different denominators. One key strategy for comparing fractions is to use benchmark numbers. For example, 4/10 is slightly less than 1/2, and 3/5 is slightly greater than 1/2. So we know that 4/10 is less than 3/5. Any number can be used as a benchmark number, but whole numbers and multiples of 1/2, 1/3, and 1/4 are most common. Another common strategy is sometimes called the missing pieces strategy. For example, 5/6 and 9/10 are both 1 piece short of a whole. Since 9/10 needs a smaller piece to complete the whole, it is greater than 5/6. A similar argument can be used to compare 49/100ths and 5/12ths, since both fractions are one piece short of 1/2. Notice this strategy requires students to be very adept at comparing unit fractions. In general, students who use these different strategies to compare fractions possess a strong fraction number sense. Another strategy for comparing fractions is to find a common numerator. For example, if we want to compare 1/3 and 2/5, we can partition all the thirds into two pieces. We can then see that 1/3 is equivalent to 2/6, and we know 2/6 is less than 2/5 because sixths are smaller than fifths. Students might also find a common denominator. For example, if we want to compare 2/3 and 3/4, then we can partition all the thirds into 4 equal pieces, and all the fourths into 3 equal pieces to create equivalent fractions. Then we can see that 8/12 is less than 9/12, which is the same reasoning students first encounter when comparing fractions in 3rd grade. Students should develop flexibility with fractions and know when it is appropriate to use different strategies. However, note that finding common numerators or denominators are the only strategies in this list that work for any pair of fractions. Furthermore, finding common denominators is especially important because it supports the work students do in 4th grade to add and subtract fractions. Finally, note that comparing fractions by finding a common denominator is a prerequisite for students' work with percentages starting in 6th grade.